p.618, number 51. Find a quadratic model for the sequence with the indicated terms. And we're given the terms 3, 3, 5, 9. We can see it's not arithmetic. We don't add the same thing every time. It's not geometric. We don't multiply the same thing every time. So it's going to be some other model. Now, if we look at the differences between each of the successive terms, we can see that we don't have a common difference. That difference changes every time. If we look at the next set of differences, we can see that there is a common difference. Now, since it took 2 steps to get a common difference, we know that this model is quadratic, y equals ax squared. If it would have taken 3, 4, 5 steps, it would be ax to the third, fourth, or fifth power. But here's what our model is going to look like. It's going to be ax squared plus bx plus c is equal to y. And we want to find a quadratic model for this sequence. Okay, so this is like saying that the first term is equal to 3, the second term is equal to 3, the third is equal to 5, the fourth, fifth, and sixth terms are equal to these corresponding values. Now I can think of the term number being my x value and the value of the term being my y value. And let's take a few of these points and plug them into this general formula. So if we plug 1 in place of x, we get 1 squared, which is 1 times a, plus 1 times b, plus c is equal to my y value, which is 3. If I plug 2 in place of x, I get 2 squared, which is 4 times a, plus 2 times b, plus c is equal to my y value, which is 3. And if I plug 3 in place of x, I get 3 squared, which is 9 times a, plus 3 times b, plus c, which is equal to my third term, which is 5. Now I can stop there because I have 3 unknowns, a, b, and c, and if I plug 3 points in there, I'll get 3 equations. If I had 4 unknowns, I would need 4 equations. 5 unknowns, I would need 5 equations. But since I have 3 unknowns, I need 3 equations. Now I need to solve this system of equations for a, b, and c. My best bet here, probably the easiest way to do this, is to set this up as a matrix. If you remember when we learned about matrices, we can make a matrix that has these coefficients 1, 1, 1, 3, 4, 2, 1, 3, and 9, 3, 1, 5. And if I get this matrix in reduced row echelon form, I'll have my 3 answers over here on the right. So let me enter that matrix. I'm going to edit matrix A, and it's a 3 by 4 matrix. And let's put those values in here. So we have 1, 1, 1, and 3. We have 4, 2, 1, and 3. And last row we have 9, 3, 1, and 5. Okay, I'm going to quit editing this matrix, and I'll get back to that matrix menu, go to the Math submenu, and I need to find reduced row echelon form, which is this choice right here. So I want to find the reduced row echelon form of matrix A. And there it is. So that tells me that A is equal to 1, B is equal to -3, and C is equal to 5. So my equation for this is going to be y equals, A is 1, so I'm going to plug that right in here, 1x squared. B is -3, so I'll say minus 3x plus 5. So now if I plug in any value, like if I plugged 5 in here, 5 squared is 25, minus 3 times 5 is 15, plus 5 gives me a value of 15. So to find the fifth term, I could plug 5 in place of x. Now I can leave it just like this. Another way we can write this answer is to say the nth term of this sequence, a sub n equals n squared minus 3n plus 5. Either answer is perfectly okay.